Good day, everyone. Welcome. Today we're going to go and learn about lambdas. Lambdas are a new core part of the language features in C++11. They're a great way to build your code with more expressive, I think, functions that are inlined within, a scope of another function or member of a function. Essentially, just if you use other modern languages, you probably are familiar with lambdas. But first, let's go ahead and start off with how you declare them. Lambdas are declared with the auto keyword because the actual type is deduced by the compiler at compile time. So you're going to need to use auto, give a name to your lambda. I'm going to go ahead and call it lambda. And then you have the square brackets, open, close, parentheses, open, close, curly brace, open, closed, followed by semicolon. Inside here is your captures, which we'll go over in a bit. And inside here are your input parameters. These are very much just like how you would use a normal function or define a function. And then inside the curly brace is the code that you're going to write. So let's go ahead and just demonstrate. To illustrate captures, I'm going to declare some local variables here. And now let's demonstrate how we can capture them. So if I wanted to use these inside my lambda, I could just name them like this. These are going to copy them. If I want to reference them, use the existing address already. That's the ampersand in front of the name is a copy, similar to how you would reference other named variables. If I wanted to use everything in scope, I could just leave it like this with the ampersand or the equal. Ampersand again being reference, equal being copy. So for now, I'm going to go ahead and print out, but I'm first going to include format. This is used in the C++20, which is what I'm compiling with. So let's go ahead and do that. Add a new line. Here we go. And now to call my lambda, it's just like you call any other function with your parentheses, open, close at the end. And let's go ahead and run it. There you go. So num1 is 100, num2 is 40, as you could see right here. All right, great. So how about input parameters? This is no different than if you just did any other normal function call. So int a, int b, return a plus b. And now my add is going to add those two. So let's go ahead and say and now I'm putting my inputs, num1, num2, calling it like a normal function. I'm going to build and run it, and we'll see that the numbers 100 plus 40 is 140. Great. Okay, so moving forward, let's talk about the algorithm library a little bit. I won't go too in depth. I just want to mainly show off the lambdas and how they work. But algorithms is a set of various algorithms that can perform an operation given like copies or iterations, things like that, onto either containers or other things that you want done. But what it will do is based upon what kind of predicate you give it. So let's start with this. Let's have a vector. And I'm going to create a vector of numbers with numbers 1 through 10. And for simplicity, let's see. I'm going to have a print vec lambda that's going to essentially print out my vector. And then I'm going to have a for each algorithm iteration. So algorithm has a for each. I could have used a for range, but I'm just going to demonstrate numbers.begin, numbers.end. This is just the first two parameters, which basically want to know the beginning and the end of my container. And here is my lambda. This lambda is going to say if the number is divisible by 2 and evenly divisible by 2, then it will equal 0, which is just the modulus operation. And if so, print out is even. Okay, so let's go ahead and see for ourselves. First, we're going to print out the vector of numbers, and then we're going to see which ones are even. Okay, so we see our 1 through 10 here, and then we see our even numbers below. Fantastic. And now let's do another little fun one. I'm going to just paste some code and go over it really quick. This here, I'm going to do an odd numbers. So now I have my vector of numbers, and in my numbers I want the condition of if it's odd. To make it a little more one line, I guess you could say, I went ahead and made this lambda is odd. It returns a Boolean. So the final output is the number passed in to the parameter divisible by 2, and is it not evenly divisible, meaning there is a remainder, because all even numbers are evenly divisible by 2. So if that's the case, then it's odd or even based on this condition. I pass that name right here at the end, because that's where the predicate needs to go in. And the other format here is just a back inserter to my odd nums, which is my declared vector here. Basically, it's just going to push the numbers into my vector for me. If I run that up and then print vec, there we go. We're going to go ahead and see that we have our odd numbers printing out after our even ones. 1, 3, 5, 7, 9. Okay, fantastic. So overall, lambdas are very simple to use, simple to make. I find myself using them a lot, especially when I find myself using the algorithms library or ranges. I recommend it a lot for those cases, just because there are times that you might be using something that's specific to the case of which you're using it for. So writing out another function in scope somewhere, it just sometimes more typing, more work than it needs to be. Sometimes if I need to and I don't want to like have this, this is okay, I think, for like 4 lines, but if I was to add more lines doing more stuff, I probably would actually do what I did here below. Make the lambda first declared as some name and then put it in here. That just, I think, looks a little nicer, but I'm still, to my mind at least, it looks just better to have as a reference and kind of not make this more messier than it needs to be. That's my preference at least. But anyways, overall, lambdas, there's a lot more to them that you could do. Overall, this is a simple approach, just getting you started. Feel free to always use them where you find where they fit. And overall, if you use lambdas in your current project, or if you like lambdas or don't like lambdas, please let me know below in the comments. And last but not least, if you enjoyed this video, please go ahead and just leave a comment or a like. And if you feel like you loved this stuff so far that I'm doing, please subscribe. Thank you again. Have a great day.